how to balance it. Let us see the new subtopic, that how to make equations more informative. Equations which gives more information about the chemical reaction is known as more informative or information giving equation. The chemical equations can be made more informative in three ways. Firstly, by indicating its physical state of reactant and products. Second, by indicating heat changes involved in it. By indicating condition under which the reaction has taken place. Okay, so we'll go one by one. First is indicating the physical states of the reactants and products. There can be four physical states for the reactants and products of a chemical reaction, namely solid, liquid, aqueous, and gas. A solid state is indicated by the symbol S. Liquid state is indicated by the symbol L. Aqueous solution is nothing but solution made in water. So aqueous solution is indicated by symbol AQ. Gaseous state is indicated by the symbol gas. Now let us see some examples. Zinc metal reacts with dilute sulfuric acid to form zinc sulfate solution and hydrogen gas is released. This can be written as Zn plus H2SO4 gives ZnSO4 plus hydrogen. Here zinc metal is solid, so we write Zn in bracket S, that is solid. Dilute sulfuric acid is an aqueous solution, that is concentrated sulfuric acid mixed with water to make it dilute. Hence we say it aqueous solution. So we write H2SO4 AQ in bracket. Zinc sulfate is an aqueous solution again, so we write ZnSO4 aqueous AQ. And hydrogen is gas as we know, so it is written as H2 bracket gas. So the equation can now be written as Zn bracket S plus H2SO4 aqueous giving ZnSO4 aqueous plus H2 gas. This equation is more informative because it tells us the physical state of the various substances involved in it. It tells us that zinc is in solid state, sulfuric acid is in the form of aqueous solution, zinc sulfate is also aqueous, hydrogen is in gas state. In some cases, an insoluble product called precipitate is formed by the reaction between solutions of reactants. So since the insoluble product is a solid substance, its physical state is indicated in the equation by the symbol S. For example, when calcium hydroxide solution, that is lime water, reacts with carbon dioxide, a white precipitate of calcium carbonate is formed along with water. This reaction can be represented by the following chemical equation with state symbols of the reactants and products. CaOH twice aqueous lime water plus carbon dioxide gives calcium carbonate CaCO3 solid form. This is nothing but precipitate H2O plus H2O. So in this reaction, calcium carbonate is formed as a solid product, that is precipitate, so its physical state is indicated by symbol S. Note that the word precipitate is written in short form as PPT. All small caps, PPT, precipitate. Since water is a liquid, so its physical state has been indicated by the symbol L. Now the second subpoint, that equation can be made more informative by indicating the heat changes in an equation. So there are two types of reactions on the basis of heat changes involved, that is exothermic reaction and endothermic reaction. So let us first see about exothermic reactions. Those reactions in which heat is evolved are known as exothermic reactions. Note this. For example, when carbon burns in oxygen to form carbon dioxide, a lot of heat is produced in this reaction. So carbon plus oxygen gives carbon dioxide plus heat. The burning of carbon in oxygen is an exothermic reaction because heat is evolved in this reaction. Exothermic reaction is indicated by writing plus heat or plus heat energy or just plus energy on the product side. Another example, natural gas is mainly methane, that is CH4. So when natural gas burns in presence of oxygen in air, it forms carbon dioxide and water vapor. A large amount of heat energy is also produced. This can be written as CH4, that is natural gas in gaseous form, plus oxygen from air gives carbon dioxide and water, plus heat energy is released. The burning of natural gas is an exothermic reaction because heat is produced in this reaction. Please note that all the combustion reactions are exothermic reactions. Also, note that whenever there is a reaction of hydrocarbons, that is compound in which carbon and hydrogen are involved, so if such hydrocarbons react with oxygen or combust in the presence of air, so in that case you will always observe that product side contains carbon dioxide and water vapor or water H2O as in product elements. There can be one, two more elements, but this two will be fixed for sure when there is combustion reaction with hydrocarbons. So another example, that is combustion of fuel such as wood, coal, kerosene, petrol and diesel are all exothermic reaction. Even the combustion of food like glucose in our body during respiration is an exothermic reaction. So let us discuss below it. We need energy to stay alive. We get this energy from food we eat. So during digestion, food is broken into simpler substances. For example, the food like chapati, bread, rice, potatoes contains starch mainly. Starch, carbohydrate actually. So during digestion, starch carbohydrate is broken down into a simple carbohydrate called glucose. Remember this all because this will help you in biology also. So this glucose then undergoes slow combustion by combining with oxygen in the cells of our body to produce energy in a process called respiration. In addition to other functions, this energy maintains our body heat. So now how this chemical reaction can be written. During respiration, glucose combines with oxygen in the cells of our body to form carbon dioxide and water along with the production of energy. So glucose, that is C6H12O6 in aqueous form plus oxygen 6O2 gives 6CO2 in gaseous form carbon dioxide plus 6H2O water liquid plus energy. So respiration is an exothermic process because energy is produced during this process. So burning of a magnesium wire similarly in air to form magnesium oxide is an exothermic reaction. So this was another small example which indicated that what exactly is exothermic reaction. What does it mean exactly? Now we'll move on to endothermic reaction. Now consider the example that when nitrogen and oxygen are heated to a very high temperature, about 3000 degrees centigrade, it's very high temperature, they combine to form nitrogen monoxide and a lot of heat is absorbed in this reaction. That is N2 plus O2 plus heat gives nitrogen monoxide. The reaction in which nitrogen and oxygen combine to form nitrogen monoxide takes place inside the engine of motor vehicles. Because temperature is involved, very high temperature is involved, we need to have a closed environment. All the decomposition reactions require energy in the form of heat, light or electricity to take place. So all the decomposition reactions are endothermic reactions. For example, When calcium carbonate is heated, it decomposes to form calcium oxide and carbon dioxide. So CaCO3 plus heat gives calcium oxide plus carbon dioxide. The decomposition of calcium carbonate is an endothermic reaction because heat energy is absorbed in this reaction. Similarly, photosynthesis is an endothermic reaction because sunlight energy is absorbed during the process of photosynthesis by green plants. Now, on the other way around, the electrolysis of water to form hydrogen and oxygen is also an endothermic reaction. This is because electric energy is absorbed during this reaction. So it is clear from this discussion that energy can be given out or absorbed in chemical reactions in the form of heat, light, or electricity. Now we'll move on to third condition so as to make this equation more informative, that to indicate the conditions under which the reaction has taken place. So conditions. So if heat is required for a reaction to take place, then the heat sign delta is put over the arrow of the equation. If the reaction takes place in the presence of catalyst, then the symbol or formula of the catalyst is also written. For example, when potassium chloride, that is KClO3, is heated in the presence of manganese dioxide catalyst, MnO2, it decomposes to form potassium chloride, that is KCl, and oxygen gas. The delta stands for heat and MnO2 is the catalyst, so the above equation shows the condition under which the reaction takes place. The condition of temperature and pressure at which the reaction takes place can be indicated in an equation by writing their values above or below the arrow sign in the equation. This will become more clear from the following example. That is methanol, that is methyl alcohol, is manufactured from carbon monoxide and hydrogen. The mixture of carbon monoxide and hydrogen gases is compressed to 300 atmospheres pressure and then passed over a catalyst consisting of mixture of zinc oxide and chromium oxide, heated to a temperature of 300 degrees centigrade. So the conditions for this reaction to take place are 300 atmosphere pressure, temperature that is 300 degrees centigrade, and catalyst which is mixture of zinc oxide and chromium oxide. Here I would like to make a note, I would like to just make you realize that currently your body is exerted by a pressure, like your body is under pressure of 1 atmosphere. So 300 atmospheres is very high. Your body is currently experiencing the pressure of 1 atmosphere by the atmosphere around us. So assume that it is 300 times. So just imagine how the pressure, what would be the intensity of the pressure when it is 300 times the pressure which you are exerted right now by the atmosphere. So it's very high pressure. So carbon monoxide plus hydrogen gives methanol is a very, very high pressure intensive reaction. The green plants make food by photosynthesis. So during photosynthesis, carbon dioxide combines with water in the presence of sunlight, and the green pigment of leaves called chlorophyll to make food like glucose and oxygen gas is given out. The condition for the reaction of photosynthesis to take place are the presence of sunlight and chlorophyll. So this photosynthetic reaction can be written as 6CO2 plus 6H2O in presence of sunlight and chlorophyll gives C6H12O6 aqueous plus 6O2. Let us understand some more examples. When methane burns in oxygen to form carbon dioxide and water, a lot of heat is produced. So this is an exothermic reaction. So reaction is CH4 plus 2O2 gives CO2 plus H2O, 2H2. Similarly, another reaction, on adding an aqueous solution of sodium hydroxide to an aqueous solution of copper sulfate, copper hydroxide is precipitated and sodium sulfate remains in solution. So the equation is as follows: CuSO4 aqueous plus 2NaOH gives CuOH twice solid plus Na2SO4 aqueous. Now, before we answer the next question on the balancing of equations, we should know something about the various oxides of iron metal. Iron, that is Fe, forms two main oxides. First, iron 2 oxide, that is FeO. This is called iron 2 oxide because the valency of iron in it is 2. The common name of iron 2 oxide FeO is ferrous oxide. Second, iron 3 oxide, that is Fe2O3. This is called iron 3 oxide because the valency of iron in it is 3. The common name of iron 3 oxide is Fe2O3, that is ferric oxide. A third oxide of iron is Fe3O4. Actually, Fe3O4 is a mixture of iron 2 oxide and iron 3 oxide. So Fe3O4 is named as iron 2, 3 oxide. The common name of Fe3O4 is magnetic iron oxide.